this is going to be the back of the homework of the independent practice for factoring expressions number 4. Now, as you walk your way through this, it may be helpful for you to take out the packet and refer back to perfect squares and to perfect cubes. So 64 does break into 8 times 8. 81 breaks into 9 times 9. This is divisible by 2, and I have subtraction, so I can move forward. 8x is come in front, 9's in the back, 1 is addition, and 1 is subtraction. Here we're working at the sum or difference of cubes. In this case, it's the sum. So a common misunderstanding is when we do the sum or difference of cubes, we have to have subtraction. That's not the case. That's only when we have a binomial that we're breaking apart as the difference of squares. Squares, two things, 8 times 8, 9 times 9. Here we're working with cubes, 7, 7, 7, 2, 2, 2, and this is divisible, this exponent on the variable, by 3. The given operation is addition. These are always opposite, and we always have addition as our last operation. Only the 7 is in front, and the 2's and the j's are in back. 7 times 7 is not 14, it is 49. Again, the 2's and the j's are in back, so 2 times 2 is 4, and 2 j's makes j squared. Now, in this position, we're going to multiply here, but we're not going to worry about the sign. 7 times 2 is 14 with a j. Moving on to number 7. Again, much like number 5. So recognize that 16 and 64 are both perfect squares. Some of you may realize that we are able to actually factor out a 16. But if you don't have that number sense, what can we do? Well, 16 is created by 4 times 4, and 64 is 8 times 8. Both of these are divisible by 2, giving us x squared, and y to the third when we divide that exponent by 2. So 4x squared is in front, 8y to the third is in back, 1 is addition, 1 is subtraction. Nothing that I've done is wrong, but to be factored means to be fully simplified. And I recognize that both of these terms are divisible by 4, so I'm going to divide out a 4. 4 divided by 4 is 1, 8 divided by 4 is 2. Same thing in back. 4 divided by 4 is 1, 8 divided by 4 is 2. Okay, now the 4's multiply, and this will be my final answer. Trying to trick you on number 8. So think of this as a 2xxxy minus 9xy. Let's start with the variables. The most x's I could take out of both terms is 1x and 1y. And other than 1, I can't factor out anything. So what goes into these two spaces when I distribute? I need 2x to the third y. So I need a 2, I need 3 x's, and I only have 1. And I need 1y, and I have it. When I distribute here, again, I get 2x to the third y. That works. Bring down the subtraction sign. 1 times 9 is 9. I have the subtraction sign. I need an x and a y, and I already have it. Can I go further? Yes, this breaks into 3 and 3. Yes, this is divisible by 2. Yes, I have subtraction. 2 is not a perfect square. This is as far as I can go. Let's look at number 9 and number 10. Number 9 and 10, we're going to practice factoring by grouping. The most I can take out here is the 1x squared. 1 times 1 is 1. I need 3 x's. 1x squared times 1 is 1x squared. And write 1x squared in back with a light question mark. What times 1x gives us a 7x? 7. Multiply to give us 7x. 7 times 1 is 7. What is next? Okay, well, let's see. They both have a 1x plus 1. In front of the first group is 1x squared. In front of the back group is a positive 7. You don't need to put a 1 in front of the x's. It's okay if you did. Looking on to number 10. Number 10. Okay, on number 10, I look at the first two, and I can factor out only a 1y squared. Inside, when I distribute, I need 3y. 3, and I have 3 y's. Minus 1, negative 1y squared. I'm going to write 3y minus 1 in back with a question mark. What times 3 produces positive 15? positive 5. Okay, positive 15y, got it. Negative 5, got it. They both have a 3y minus 1. In front of the first is 1y squared. In front of the second is a positive 5. And we're done.